Hi folks, welcome back to Physics with Captain Rod. I'm going to make this one here to help you out with number 18 in your homework. So for each electron transition, calculate photon frequency and wavelength, classify the photon on the EM spectrum. Are any of these visible, yes or no? So we're talking about a hydrogen atom. I think that should have been specifically mentioned in the problem. I'll go back on the next version and put that in there. But in a quick little reminder, so hydrogen atom, you've got the nucleus where the proton resides. Then the electrons, they live in these regions called shells. There's the first shell, second shell, third shell. Then there's what's called a quantum number for each shell. The first one is the n equals 1 shell, then the second and third, and so forth. And the first shell is referred to as the ground state. Then remember, there's a way to calculate the energy per shell, and that's minus 13.6 electron volts over n squared. So what I would do here is calculate E1, and that's pretty easy. Put a 1 in, you get minus 13.6 electron volts. Then we're going to calculate energy 5. So energy 5 is going to look like minus 13.6 EVs over 25, and this is a decimal, some number. I'm just going to put a number here, all right? Now, when the electron goes from the fifth shell to the first shell, let me kind of draw what happens here. So let's say here's our fifth shell here. Here's our electron. It has an energy equal to energy 5, which is this number. When this electron drops down, it gives up a photon. Right? And then the basic math is this. The amount of energy you start with, energy 5, has to equal the sum of these two, the energy of the photon plus energy 1. It's just like if I start with $20 and I give 5 away, I now have 15 left. And math-wise, $20 is equal to what I give away, the 5, plus what I have left, 15. Energy 5, right, is this number, so that's going to go here. Energy 1 is this number, that's going to go here. And when you calculate the energy of the photon, you're going to get a positive number out of it in EVs. So some positive number, right, in electron volts. So the next step, take that number in EVs and we're going to convert it to joules. So times 1.6 times 10 to the minus 19th joules per EV. You will now have a number that's in joules. Okay, next step to get the frequency. The energy of a photon is equal to h times f, where the h is called Planck's constant. And I can't remember what that is off the top of my head. I'm going to have to look that up. Give me a moment here. I kind of forgot it. And if I forgot it, that means you don't have to remember it either. Just give me a moment here. Okay, that number, Planck's constant, you can use 6.63 times 10 to the minus 34th. Units come out in that to joule seconds. All right, so you're going to take this number, and that goes there. And then Planck's constant is this, and that's how you get the frequency out of it. Basically, you're going to take this, divide by this. Now, once you have the frequency, all right, it says and wavelength. Okay, so for all EM radiation, the speed of light is equal to frequency times the wavelength, where this value is 3 times 10 to the 8th meter per second. This is true for all electromagnetic radiation. Then you take your frequency, that's going to go there, and you calculate a wavelength. That's what that thing is. So again, this number and this number, these are good for all EM radiations, okay? So that should, that's how you do A, B, C, all of them. Quite a bit of work, I realize, on these problems, but that's okay, all right? Anyway, I hope you enjoyed this video. Have a great day.